Hello, and welcome back to another IB Math Speedrun with me, Vince. In this speedrun, we're going to be going through Chapter 11.2, which is all about probability distribution. So let's jump right in. So the first distribution we need to talk about is a discrete random variable. We've already met this variable in, I think it was Chapter 5, but it's one that can take discrete values. So it can take, say, it's the number of kids in a class. You can only have integer values, and you can't measure it any more precisely than an integer. The actual number of kids in a class will vary between classes, so that's why it's a variable. And so we often use sigma notation to express, we often use normal probability notation to notate a variable. So a discrete random variable looks something like this, where we have the probability of the variable, which is x, being a certain value, which is this smaller x, is equal to some p, where p is the actual probability. So p, capital P probability function, capital X is the variable, lowercase x is the value, lowercase p is the actual probability. And so for discrete random variables, the sum of the probabilities must always equal 1. So we can write this as p as x equals x is equal to 1. So the sum of all of the possibilities of the variable must be equal to 1. Yeah. So now we can jump into some questions. So the first one is determine whether the following probability distribution functions are valid. And so the first one is oh, where is it? Sorry about this. Where is the question? Okay, so the first one is this table over here. I mean, we only have to do one. And so we have the value of the variable and the probability that we get that value. And we have the values 0, 1, 2, 3, and 4. And as you can see, because these are like actual values and not ranges, this is a discrete variable. So the probabilities we have is 0, 0.1, 0.2, 0.3, and 0.4. So to check whether this probability distribution function is valid, we need to make sure that the sum of all the probabilities is equal to 1. So in this case, 0 plus 0.1 plus 0.2 plus 0.3 plus 0.4 does indeed equal 1, and so this probability function is indeed valid. Okay, next, we need to by drawing the probability distribution table, determine the following functions describe a discrete random variable. If a discrete random variable is described, find the mode and the probability that the variable will be greater than 3. So the first case is this function. We only have one actually. Okay, cool. So we have one case. So the probability of x, of capital X, being equal to a certain number is equal to 1/2 x cubed for x is equal to 0, 1, 2, 3, and 4. Okay, so let's calculate the probability distribution table and see whether this is a discrete random variable. So we have x and the probability that it gets x. We have 0, 1, 2, 3, and 4. And we have 1/2 x cubed. So 1/2 of x times 0 is 0. 1/2 of 1 is 1/2. 1/2 of 2 cubed is 4. 1/2 of 3 cubed is 27/2, and 1/2 of 4 cubed is 32. So is this a discrete random variable? Well, no, it's not clearly, since some of these probability functions are over 1. And in a discrete random variable, remember, all of these have to add up to 1, and this clearly does not add up to 1. It adds up to something much, much greater than 1. So it's not a variable. Okay, and so finally, we have the discrete random variable has PDF given by, interesting, and PDF is probability distribution function. So the probability of x is equal to kx. X is equal to 10, 11, and 12. So first, find the value of k. Next, find the mode. And finally, find the probability x takes an even number. Does this mean... Okay, so what they mean actually is probability of x is equal to x is equal to k of x. So what we have here is we need to know that 10 times k plus 11 times k plus 12 times k must add up to 1, since these are the three possible values that this discrete random variable can have. And so therefore we have k is equal to, I think, 1/33, because 33k is equal to 1. So k equals 1/33, so that's k. The mode is going to be 12. That's pretty obvious, since 12/33 will be the largest value for the probability. So the mode is the discrete value with the largest probability. Finally, find the probability x takes an even number. The even numbers are 10 and 12, so we have 10/33 plus 12/33, which is equal to 22/33, or 2/3. So there's a 2/3 chance that x will be an even number. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.